So it's come to a couple of times recently with a couple of students of mine, and they've asked, how do I complete the square when the number next to x squared is greater than 1, when a, the coefficient, is greater than 1? So I've just set up a couple of scenarios here. As you can see, the left-hand side, much easier than the right-hand side, but let's crack on with them both. The main principle is you cannot complete the square while there is a coefficient of x squared. You need to remove it. If you get it out of the way, if you take it out of the x squared term and the x term, and then focus all your concentration on completing the square on just the inside part, just this bit. Everything else, leave it alone. Leave the 2 alone. Leave the -9 alone. They don't come back into play until you've finished completing the square. Stick with the technique that works from the last video. Halve the number next to x. If you're on a calculator paper, fractions or decimals, whatever you fancy. But definitely without a calculator, halving and squaring and taking away, simply square the top and square the bottom. Squaring fractions is much easier than squaring decimals without a calculator, and you'll definitely see that come into play on the next one. So now is the point where you bring the 2 back in. 2 multiplied by that term, 2 multiplied by that term. For the first term, dead easy. Just put it in front. That's all you need. And in most exam situations, you've pretty much got 2 marks. You've got 1 and you've got 2. You just need to get the pieces of the puzzle for the final part. When you double a fraction, you can double the top. 50/4 in this case would be fine, but I prefer the slightly quicker way of halving the bottom. All right, whoops. Yeah, that's right. So halving the bottom, I could have done 50/4, but 50/4 cancels down to 25/2. And the final trick, change the 9 into the same sort of fraction so they can be easily simplified. Negative, negative, so it's -25, -18. We've got a -43. And just leave it. No point in mucking around with it. You can now use it for whatever you need, finding coordinates of vertex or whatever. When it's a slightly harder looking one, when the coefficient is not a factor of the coefficient of x, carry on. It doesn't matter, but stick with fractions, because otherwise taking a 3 out would get very messy. Take a 3 out. Now, when you take a 3 out of 7, it doesn't work. 3 does not go into 7. So in this situation, I could have written 10/2, because 10/2 is the same as 5. 10/2, though, you don't like that. You write 5. But here, I can write 7/3. That's how you take a 3 out of 7. Because don't forget, factorising is the opposite of expanding. If I expanded this, I'd be to my starting point. Same process as before, just slightly cleverer on the fractions. So complete the square on the inside part. Again, you halve a fraction. Best way, halving a fraction, is double the bottom. And even though the number's slightly more awkward than before, just carry on, the method works. Square the top, square the bottom, off we go. Now you need to remove the square brackets, same process. Nothing's changed. And again, you've still earned your 2 marks out of 3. You now just need to make sure the final part for the 3rd mark is spot on. So I'm going to treble this fraction. I could times the top by 3 for 147. What's the point? I just have to work to cancel it down. So I'm going to divide the bottom by 3. And then I'm going to write the number 8 in a daft way. I'm going to write 8. 8 12s are 96. Because that creates the possibility of just adding and subtracting the numerators. So let's finish off the job. I haven't worked it out in advance. So minus 48, minus 49, we'll add 100, we get to 51. And then we've got 45 left. No, we haven't. We have got 57 left. That gives us the 96. And that should be a positive. Tricky, yeah, all right, but make sure you just get your fractions practiced. And it's all about when you double the top, it's the same process as halving the bottom. You just reduce the extra complication of having to cancel fractions down or having numbers bigger than you need to. And again, you've now got all the information, transformations, where the vertex is, all the information is stored in there. So I hope that's helped. All right, hope I got it right, but I hope that helped, and I'll see you on the next video.